Dr. Raj Reddy is a pioneering figure in the field of computer science whose groundbreaking work has left an indelible mark on the way we design and utilize computing systems today. Dr. Raj Reddy was born into a Telugu family in Chittoor district of Andhra Pradesh, India. His father was a landowner and his mother was a homemaker. He was the first in his family to attend college. After earning a bachelor's degree in civil engineering from Gunidi Engineering College at the University of Madras, he interned in Australia. At the University of New South Wales, he began using the English Electric Deuce Mark II computer. He graduated with an M.Tech from University of South Wales in 1960, then joined IBM as an applied science representative. In 1963, he started his PhD at Stanford University under John McCarthy, becoming the first PhD in AI in 1966. After 3 years on Stanford's faculty, he joined Carnegie Mellon University to collaborate with AI pioneers like Alan Newell and Herb Simon. Dr. Reddy's work spanned various domains, including computer architecture, parallel computing, and artificial intelligence. He is best known for his contributions to the development of ternary computer, a novel architecture based on ternary logic, as well as his work on parallel algorithms, speech understanding systems, and expert systems using artificial intelligence. These ideas were truly ahead of their time and laid foundations for many of the high performance computing techniques we rely on today. Dr. Reddy's exceptional accomplishments have been recognized with numerous accolades, including the prestigious Padma Bhushan, one of India's highest civilian honors, awarded in 2001 for his pioneering contributions to computer science and artificial intelligence. In 1994, Dr. Reddy received the Turing Award, considered the Nobel Prize of Computing, for his groundbreaking work in artificial intelligence. The Turing Award citation specifically highlighted his contribution to the founding and vitalization of artificial intelligence through his work on systems like hearsay and development of production rule systems. His other awards include the prestigious Vannevar Bush Faculty Fellow from US Department of Defense, the Legion Honor, a prestigious French civilian honor, and the Honda Prize in 1989 for his pioneering work on robotics. If we dive deep into his work, during his doctoral research at Stanford University in 1960s, Dr. Reddy embarked a pioneering project that would shape the course of his illustrious career. The development of ternary computer and architecture based on ternary logic rather than the conventional binary system. An instruction set architecture or ISA defines the basic low-level interface between software and hardware. Unlike conventional binary computers that use zeros and one, Dr. Reddy's system used ternary logic with three values, 0, 1, and third value often represented as U or unknown. This allowed for greater information density and the ability to handle uncertain or incomplete data, which proved valuable for AI and pattern recognition tasks. The key features and innovations of the ternary instruction set architecture included special ternary logic operations beyond simple and or not, support for parallel processing with simultaneous execution of multiple instructions, pipelining techniques to improve instruction through output, ability to handle uncertain or incomplete data through the unknown value. Dr. Raj Reddy's contribution to parallel computing went far beyond his pioneering work on ternary architecture. During his time at Carnegie Mellon University, he delved deep into developing parallel algorithms for solving complex AI problems. From planning and scheduling to knowledge representation and reasoning under uncertainty, Dr. Reddy and his team explored how parallel processing could tackle these intricate challenges. But theory alone wasn't enough. They built experimental parallel systems to evaluate and test these algorithms on actual hardware. His quest for parallelism extended to architecture realm. where he explored novel parallel architectures, programming models, and system software explicitly designed for coordinating and scheduling parallel tasks efficiently. His insight in this area were truly visionary. Moreover, Dr. Reddy was a pioneer in recognizing the potential of distributed parallel systems long before they became mainstream. He worked tirelessly on fundamental challenges like maintaining memory coherence across distributed nodes and avoiding deadlocks in these complex environments. His groundbreaking work on distributed parallel processing laid the foundation for the design of modern large scale parallel systems that power today's supercomputers, clusters, and data centers. From pipelining and hazard handling in modern superscalar processors to VLIW, also known as very long instruction words, and other parallel instruction execution model, Dr. Reddy's influence is evident. In the 1970s and 1980s, Dr. Reddy made significant advances in the field of AI, particularly in knowledge based systems and expert systems. He was one of the key researchers behind the development of OPS5 language for programming production systems. OPS5 became an influential tool for building expert systems and exploring AI techniques like pattern matching, rule based reasoning, and knowledge representation. It was used in several early expert system projects, including the Prospector system for mineral exploration. One of his most well known AI projects was Hearsay series of speech understanding system developed at CMU. He led the team that created Hearsay 1 and Hearsay 2, which were among the first attempts to build intelligent systems that could understand continuous speech. About Hearsay 1, it was an influential early experiment in applying AI techniques to the problem of speech recognition and natural language processing. It used the Blackboard architecture and knowledge sources to integrate different levels of knowledge for speech understanding. About Hearsay 2, it was built on the concept of Hearsay 1 but was a more advanced and comprehensive speech understanding system. It introduced the idea of parallel processing and hypothesis scoring, with multiple knowledge sources working in parallel to generate and evaluate hypotheses. It demonstrated the potential of AI techniques like backboard architecture, knowledge representation, and hypothetical reasoning for complex problems like speech recognition. While it didn't really achieve the goal of fully understanding continuous speech, they pioneered important AI concepts and architectures that influenced later work in areas like Blackboard system, multi-agent systems, and integrating multiple knowledge sources for complex reasoning and tasks. Going through his research paper, I can confidently say that Dr. Reddy used great an analogy to explain the readers. Dr. Reddy's contribution to AI extended beyond just the technical aspects. He was a driving force in establishing AI as a respected field of study and research through his work at CMU and as the founding director of Robotics Institute there in 1979. As the director of the Robotic Institute, Dr. Reddy played a pivotal role in shaping the curriculum and research agenda, attracting top talent, and fostering interdisciplinary collaboration between computer science, engineering, and other fields. The institute became a global hub for cutting edge research in robotics, computer vision, and areas related to AI. Through his career, Dr. Reddy has mentored and inspired countless students and researchers, many of whom have gone to become leaders in their respective field. His relentless pursuit of innovation, his ability to challenge conventional wisdom, and his unwavering belief in the potential of AI have left an indelible mark on the field. Even today, at the age of 86, Dr. Reddy remains actively involved in various research initiatives and continues to share his insight and wisdom with the next generation of computer science and AI researchers. Here is the list of sources used to provide information over Dr. Reddy's work.